All right, everybody, we're going to pick up where we had to take a quick pause because the video was going to get a little too long. We are going to go ahead and right now do our next pivoting. So we need to change this 0.5 entry into a 1. In order to do that, we multiply, it's a half, so we need to multiply by 2. But I'm going to do that over here. So 2 times row 1 will be our new row 1. Once that becomes a 1, we need to change everything else into zeros. So it looks like we're going to do negative 20 row 1 plus row 2 to create a new row 2. We're going to do negative 0.5 row 1 plus row 3 to make a new row 3. And we're going to do 50 row 1 plus row 4 to make a new row 4. Okay, so here we go. We've got all of our instructions written out. So a second matrix math again. This time we first need just a times row. We're multiplying 2 in matrix A, and we're doing this to row 1. Store it. Okay, so I'm going to copy down my new row 1. It's 1, 0, 1, 2, 0, negative 1, 0, 40. Okay, so it's another second matrix math times row plus for the rest of them. This time we're multiplying negative 20 in matrix A. I'm doing this to row 1 to change row 2. Store in matrix A. Okay, so I have my new row 2. It looks like it's 10, 0, 0, negative 40, 1, 10, 0, and 80. Okay, 2 more times. Get into another times row plus here. This time we're doing a negative 0.5. Oops. That's not what I want to do. Delete that. Start again. Hit the wrong button. Okay, so this time, sorry, we're doing a negative 0.5. Second matrix, there we go, A, to row 1 to change row 3, and then store again. Okay, so our new row 3 looks like it's 0, 1, 0, negative 1, 0, 1, 0, 60. One more, and hint, hint, this is going to get us optimal. So this time we're doing times 50. Matrix A to row 1 to change row 4. Store it again. So it looks like we've got 100, 0, 0, 100, 0, 100, lots of hundreds, 1, and 26,000. Wow. So we started at a 0 profit, we improved to a $2,400 profit, and we finally reached optimal at $26,000 profit. So I'm glad we kept going to find this optimal value here, because that is what P is going to be. P is going to go over to the 2600. Let's look for our other unit columns. Got, okay, so it looks like X1 is 0 because it's not a unit column. X2, this 1 goes over, so X2 is 60. X3 is 40. Y1 is a 0. Y2 is an 80. And Y3 is a 0. Okay, so I don't know why this ended up so far down, but it did on the screen here. So the farmer will obtain a maximum profit of, so we know his maximum profit is $26,000 if he plants, and I rewrote it down, X1, X2, and X3 were standing for crops A, B, and C. So it would be if he plants no acres at all of crop A, 60 acres of crop B, and 40 acres of crop C. So what we can notice right here is he did use all 100 acres, right? He had 100 to use, and he planted 60 with crop B and 40 with crop C. So he did use all of his acreage. Nothing went unplanted. A couple other observations. It says, will the farmer use all of his allotted seed money? If we go back, way back to the beginning, his seed money came from that second equation. So if we look at that, if we kind of copy that back down, his seed money was 40x1. So in that case, that's 0 here, plus 20x2, which happened to be the 60 in this case, plus 30 times x3, which was 40, is what we just found. And we want to know, what does that equal? It was supposed to be less than or equal to 32. That's $3,200 is what he had to spend. So does he spend it all? Well, let's see. This is 1,200 plus 1,200, which is 2,400. So no, he doesn't use it all. He actually has $800 left. And what's interesting here, how you can match this up, is if you check out what else was 8, where was there? Oh, I made a mistake up here when I was writing this down. If I look back over here on my screen, I'm like, where is that? This number right here should have been an 800. If you caught that, good for you. I had it correct in my calculator and I wrote it down incorrectly. But notice that that's actually what y2 is. y2 is the value 800. And remember what y2 was. It was a slack variable that we added to that initial inequality to make it an equal. So we're saying in this one right here, we said, hey, if we add 800 to this, it actually would equal exactly 3,200. So that's really interesting. That's what the slack variables tell you. They tell you, is there something like left over that we would need to add to this to actually hit that maximum? Well, in the first one, there wasn't. For y1, x1, x2, and x3 all added up. We didn't actually need to add anything to that to equal 100. He was going to hit 100 anyway. For the second one, there was something that needed added. He would have to add $800 more to hit that max amount. So that's what these y1, y2, and y3 tell us. They tell us those are those slack variables. Was there anything left over, basically? So yes, he did have some seed money left over. What about his allotted work days? Well, we should be able to look up here, and y3 was what was added to the work days. y3 says 0, so we would need to add nothing to the work days one in order to hit his max. So if we check this, we should say that yes, he uses all of his allotted work days. And if we check it in that original inequality again, it was 1 times x1, which in this case is 0, plus 2 times x2, in this case was 60, plus 1 times x3, which in this case we're saying is 40, and that was less than or equal to 160. That was the original. And if we actually check that out, we get 120 plus 40. We get exactly 160. So it works. Did he use everything? Yes. He used all of his allotted workdays. He had a little bit of money left over. He used all of his acres, and he maximized his profit. So that's how all of those values work together.